Yes, hello guys. So today I'm talking about further application, moment of inertia, of a body. So moment of inertia in multiple integral application. Application of multiple integral we are further. In the further discussion is moment of inertia. These questions, as I always say, are taken from the students' queries, online queries, in the class study queries. Now, before that, let me first define that what is the moment of inertia and how it is to be calculated. Working rule I'll talk about that, how to work out what is the proper rule of this. And then what is the radius of gyration is also sometimes calculated. Sometimes out. Is sometimes asked about. So what is radius of gyration? I'll talk about radius of gyration and moment of inertia. So let me talk about what is moment of inertia. If I take, there is a point of mass, let me take, this is a point of mass m here. It is mass is equal to m. Now its perpendicular distance of this point that we take from a line, this is the line, its perpendicular distance is small r. And the mass of this point is m, small m. Then moment of inertia is, let me write here, if the mass of a point is small m and its perpendicular distance from a line is r, let me take r here, then Mi or moment of inertia is known as moment of inertia. Moment of inertia. Mi or moment of inertia is given by, let me take the formula is either write Mi or simply I is equal to m into r square. This is moment of inertia given by of a point. Given by this formula. So this is the first question. And what is r here? R is the perpendicular distance here, where r is perpendicular distance. This is symbol for perpendicularity, perpendicular distance from a line of a point, perpendicular distance of a point from a line. This is line, suppose, and the distance is r here. R is the perpendicular distance of this point. If I take this point as P, so this point mass is m, then moment of inertia is given by, if I take I, and this is equal to this. If there is a body given to us, let me take, if there is a body, the mass of which is continuous mass, and if I take number of points here, let me take, this is the point, this is the point, this is the point, and so on. And so on. This body is constructed with the help of smaller masses. Let me take, this is M1, M2, M3, M4, and this is, let me take, Mn. And the distance, perpendicular distance of these points, from the line is r1, let me take, the distance of this point is r2, let me take, this is r3, this is the perpendicular distance. And let me take, this is r4, and this is r4, and finally this is rn, perpendicular distance all are. Perpendicular distances. Then what is the mass of this whole body? The mass of this whole body, or moment of inertia of this whole body, will be given as m into r square, where r is the sum of all these values, all these MIs, moment of inertia. So moment of inertia of the whole body is sigma mr square is equal to m1 r1 square plus m2 r2 square plus m3 r3 square, r3 square plus m4 r4 square plus and so on. Last is mn square and mn into rn square into rn square. The sum of all these MIs, moment of inertia, is equal to the moment of inertia of the whole body. Sum of this of these masses. Where capital M, if I take this is small m, I have taken, but if it is capital M, then capital M is equal to m1 plus m2 plus m3 plus mn total mass of the body. Okay, so this is how moment of inertia of a point or of a body given about an axis or about a straight line. The distance of that point or that mass from that straight line is found out, is a perpendicular distance which we find out or which is to be calculated, and after that we find out what is moment of inertia. The formula is this: I equal to mr square. Now let me take different positions. Now if there is an arc or a straight line, or we say the length of an arc, the moment of inertia of that arc or a wire, let me take, okay, anything. So the moment of inertia of a wire is calculated. Now first let me find out what is the moment of inertia, Mi, of an arc or of a length or wire, maybe this is an arc. Okay, so length of, so Mi of that length is given as is equal to, let me take sigma mr square, where r is again perpendicular distance of this wire. Let me take, this is the wire here and this is the smaller disc here, the ds distance, the length of this arc is ds, this smaller element is ds for example, and the distance of this from a straight line is r, perpendicular distance. Okay, then and mass is dm, let me take small dm. So sigma mr is equal to, this is dm into r square, or you may say sigma dm into r square, or we can write this is equal to sign of integration dm into r square, okay, into ds we may write, or we may write dr here. Okay, the distance is whatever ds is given to us. This is given as mr square. So this is equal to finally m into r square, total value mr square, which is finally calculated. But this summation of sign is converted into integral sign, writing dm and r square can be taken outside. If it is r square, it will take here, this is r square here. If it is integrated with respect to this is dm only, sigma dm, but ds is just only for the distance r here. Okay, but r is taken outside, then sum of the mass, total mass, is m square into r square. Okay, and if I take, let me take, if I, the moment of inertia, the moment of inertia is equal to, let me write here, I is equal to, we know that this is nothing but mr square, or this is equal to sigma dm r square into sigma dm, or is equal to, if I take it as m into k square, k maybe g square, let me take g square, where g is the radius of gyration, g square, then g is The radius of gyration, known as the radius of gyration, the radius of gyration of the body, of the mass or body. Let me take here the mass of the point of the mass about the line, whatever line is given here. This is radius of gyration, means to move around. This is the radius of gyration, where g is g square, or r we take r, but g square here, or g is known as g is the radius of gyration. Sometimes the radius of gyration is to be calculated. Whatever this value is given, we find out the mass. Then moment of inertia divided by mass will give us g square. Then square root of that will give us g, or radius of gyration. Radius of gyration is calculated by dividing mi, moment of inertia, divided by mass, total mass, will give us the radius of square of the radius. Then square root of that value will give us radius of gyration. Okay, so finally, what is radius of gyration? This is radius of gyration if this body is moved around this straight line like this. So this is known as movement radius of gyration. Radius of gyration, which is forming a circle. If I move this part of this mass around this line, that will be known as moment of radius of gyration. This is radius of gyration. For this, when this mass is moved around this line, it will make a circle. The radius, this is the radius of that circle. Radius of gyration, if I note down this by g, then this is radius of gyration. Radius of gyration is the radius which which is the length of the distance, or that perpendicular distance from the given line of the point. This point is moved around. Now if I find out what is the moment of inertia of a plane around the axis, let me find out that also. Now second point is moment of inertia. Moment of inertia of a plane area, around the axis, around the axis of x and y, around the axis of x and y. Let me take here x and y axis. This is x axis, we know about this is y axis, y dash, and this is x axis, this is y axis. So if I take here the point, let me take this point P is having coordinate x and y. So what is the x and y? If I draw perpendicular to the axis of x, let me draw perpendicular. Okay, and this is perpendicular here. The distance is x. The x coordinate up to this point. This is suppose A, P point. Okay, and this is y here. Now, if I find out what is the moment of inertia of this point, let me take this point as a smaller mass. Okay, this is dm here. Okay, the mass of this small element is dm. Okay, part of mass. So this is elementary mass of this part. So may be taken as a area. Okay, so plane area around these two axes, around the axis of x. Around the axis of x, if I find out, then perpendicular distance is y, this y coordinate. So this is perpendicular distance y. If we find out the moment of inertia of a point around the x-axis, it will give us m into y square. Or if I find out that the density of this mass is rho, then rho into dx into dy into y square. What is the mass of the? Let me find out the moment of inertia. The first part is moment of inertia. Moment of inertia of the plane. This is smaller plane. If I take this is smaller plane like this. Okay, the smaller mass is dm of the smaller element. Then, or we can take a square or rectangle, whatever rectangle is this, and or a square. That is to be calculated. So, moment of inertia of a plane having a point P x by with elementary mass dm, which is equal to rho into dx dy. Rho is the density per unit. Okay, dm, where rho is the here. The rho is density per square unit. Density per square, which is uniform density. Density per square unit. Per square unit of the plane lamina. Of the plane lamina or plane area. Plane lamina. Okay. Then moment of inertia. Then its moment of inertia. The moment of inertia of the plane around, not around, but about, if we take about x-axis, about axis of x or x-axis is equal to, we write sign of double integral, this is area integral here. Okay, rho into dx dy, but before that we write here y square. Why y square? Because this y is the distance, perpendicular distance of the point from the axis of x, is y square, rho into dx dy. This is the mass here, total mass, double integral rho into dx dy. This is the mass dm. Okay, so mass, total mass m. This is m into y square, we can write. This is the equation of moment of inertia around the axis of x. See, let me write down this by moment of inertia M.I.F here. This is moment of inertia, or simply write Ix or Mx, moment of inertia, or Mix, no problem. So let me write Mix. Okay, or and Mx. If I find out the moment of inertia and draw perpendicular from this point to the axis of y. So axis of y, this is the x coordinate here. This x coordinate from this distance, same. They are same. Opposite sides of the rectangle or the square, they are same. This is x here. Therefore, perpendicular distance, okay, from the y-axis of this point is x. Therefore, moment of inertia about y-axis of this point, and let me write here, and moment of inertia, and the moment of inertia of the plane about y-axis, about axis of y or about y-axis, axis of y is given by, let me write Iy or M by MIy. Okay, moment of inertia y is equal to, again, area integral, double integral, x square here into rho dx dy. This is density here, rho dx into dy. Whatever rho is given, density is given. That density into dx dy. So we have to integrate this x square with respect to x and y respectively. This will give us the moment of inertia about the axis of y. In the axis of y, moment of inertia, we get x square. In the axis of x, moment of inertia, we get y square. This is to be understood. Why? Because moment of inertia of this point about x-axis, this distance is to be called, this is perpendicular distance here. Perpendicular distance square, y square here. In this case, it's x square. Okay, so this is what we find moment of inertia of a plane area or of area, okay, around the axis of x and axis of y. Now let me find out the moment of inertia of a solid. Three-dimensional figure. So now let me take that. The moment of inertia of a solid, okay, around the axis There are different axes here, x, y, z. So the third point is moment of inertia of a solid about the axis, x, y and z axis Okay, so that we have to find out. Suppose if I take this is y axis, this is x axis, this is z axis. Okay, and we can take like this. This is there just below them. Okay, and this is z axis, this is x axis here. Okay. Now, if there is a body, if I put it here in the of mass m, let me take, or rho density having rho dx dy dz. This is the mass, total mass of the body, density into per unit, okay, or elementary volume of this body. This is dx dy dz into rho. That is equal to dm here. Dm's elementary mass of this body is rho dx dy dz. Similarly here, dx dy dz. But we have to find out what is the perpendicular distance of this line. So let me write here. First point in this case, moment of inertia M.I. of a solid about, okay, or in the about of a solid about the axis of x and y, okay, or around, let me take about the axis of z. Okay, M.I. of a solid about the z axis. If I find out z axis, or okay, or in the plane xy plane of a solid about the axis, x, or in the, if the body is lying in the z axis or z plane, around the z plane, okay, then we have to find out x and y. In case of this, of the axis of x and y, okay, this is about z axis. About z axis, if I have to find out, or about z axis, and it will give us moment of inertia. This is now volume integral, triple integral. It will give us x square plus y square z square equal to x square plus y square into dx dy dz, where this is rho into dx dy dz. This is x square plus y square, because this is about z axis. Okay, and secondly, M.I. moment of inertia of a solid about, now this is x square plus y square of z. Now around the axis of x, then it will be y to z square. About the axis of x, x is about the axis of x, about the axis of x. So in the plane y and z, or axis of y and z, it will give us moment of inertia volume integral. This is y square plus z square into rho dx dy dz. Okay, this is second equation. Third one, now moment of inertia or M.I. of a solid about the y axis, about the axis of y, or in the plane x by xz, in the plane xz. With that, this will give us volume integral again. Now this is x square plus z square. This is about x over y. So, or z square plus x square. We write first z square, then x square. Z square is x square into rho dx dy dz. This is denote the mass, and this is the perpendicular distance of that body in the plane zx plane. Okay, from the xy, from the y or along the y axis. Distance of the point in the y axis, from this plane x and z plane will be x square plus z square. This is how we find out moment of inertia about the axis. Okay, different axes. About x axis, z axis, x axis. In multiple integral or triple integral or multiple integral. So this is how we find out moment of inertia. Now let me take the questions one by one. What are these questions? Let me talk about this. First question, let me take, then it will be very clear that how to find out moment of inertia. The working rule is simply we draw the figure, geometrical figure, and after that we find out what is the mass of the body given and the perpendicular distance of the that body or that mass. Okay, about that axis from that line or that straight line, that axis either axis of x, axis of y, or axis of z, whatever. Okay, so we find out the perpendicular distance and then and the mass of the body. Multiply the square of that distance, perpendicular distance, and the mass of the body. So this is what we find. Now, question number 1 is, let me take that. Now, question number 1 says that what is the find the moment of inertia of the mass of the tetrahedron. This is tetrahedron here by the coordinate planes. Okay, by the coordinate planes, mass of the tetrahedron by the coordinate planes, and the plane this one about z axis. Now, about z axis we have to find out. Assume the density to be uniform throughout. The density is uniform throughout. Density, if I take as lambda, suppose, or any constant, let me take the rho, simply rho. Rho is the density. Assume the density to be uniform throughout. So rho is the density here, if I take, and then what is the, okay, so first we have to find out what is the perpendicular distance about the z axis. About z axis, it says find out what is given to us. Let me write here. Given here the equation of the tetrahedron. Okay, a tetrahedron by the coordinate planes and the plane here, a tetrahedron and the plane. This is x upon a plus y upon b and z upon c is equal to 1. This is the plane, equation of the plane here. And the moment of inertia of the mass of the tetrahedron. Now, tetrahedron means, let me write here. This is the geometrical figure here. Tetrahedron is like this. Tetrahedron figure. Okay. So this is z, this is y axis, this is x axis. So at this point, if I take any point here, first of all, what is the perpendicular distance from about the z axis of this plane area? So let me find out. So what is solution here? Let me write. A perpendicular distance of the tetrahedron about the axis of z or z axis, about the z axis. Of the z axis is given by square root. This is the perpendicular distance, x square plus y square, or z square equal to x square plus y square. That is perpendicular distance here, or z square equal to x square plus, this is perpendicular distance here, that we will write down. Now what is the moment of inertia? Therefore moment of inertia, first let me write the formula. Moment of inertia of the tetrahedron about the z-axis is given by triple integral sign. Now this is z square here, but this is x square, this is y square for the z-axis into rho dx dy dz. Now if I write here in this plane, let or putting let small x equal to a into capital X, small y equal to b into capital Y, and z equal to, let me take c into capital Z. Therefore dx dy dz equal to a into dx, a into dy, like this. This will be equal to, so therefore small dx equal to a into capital dx, okay, and dy is equal to b into capital dy, and dz equal to small c into dz, capital dz. That we will write down. Now therefore this equation will be converted as x plus y plus z equal to 1. Therefore what are the limits here? X equal to 0 will give us x equal to 0, then z equal to 1 minus x minus y, okay, y equal to capital Y, this is capital Y here, 1 minus x, okay, and so these are the, and x equal to 0 to 1 limits we will substitute, and x equal to 0 to 1 limit we will substitute, y equal to 0 to 1 minus x, y equal to 0 to 1 minus x, z equal to 0 to 1 minus x minus y. These limits we will apply in this equation. Okay, let me first find out what is the equation given to us. In the rho dx dy dz, either write rho here, lambda here, because this is uniform density given to us.